You're not going to want to miss this episode of the AI Show where Jeremy Howard takes us through how to be a deep learning practitioner. You don't even need a PhD. He's going to give us all the details. Make sure you tune in. Hello and welcome to this special edition of the AI Show where we've got a special guest, Jeremy Howard. We're going to talk about how to actually build applications, AI applications, without really needing a PhD, something I don't have. Jeremy, why don't you tell us who you are and what you do and how you got involved with AI?
Sure. So I'm the co-founder of fast.ai. Fast.ai is a research, teaching, and development lab based in San Francisco. And our specialty is deep learning, and specifically about making deep learning more accessible. We've been doing that for a few years now. We have what might be the most popular course in the world for deep learning. We have one of the world's most popular software libraries for deep learning. And our research have developed some of the world's most important new algorithms for deep learning. And we also have a fantastic community of tens of thousands of people who help each other out and help me out on our deep learning journeys. It's been a real pleasure, and it's been exciting to see the impact it's had so far.
So how did you get involved with AI and specifically deep learning? Look, I went to school when SVMs were all the rage, and to me, they were beautiful because mathematically they were convex functions, and it did really cool stuff. How did you shift over to the world of deep learning?
Sure. So I was kind of the opposite. I guess, well, I was, 10 years ahead of that maybe. So I was kind of starting my working life when neural nets were last huge. And I was using them in banking, I was using them in marketing. I thought they were fantastic. But we had to spend literally millions of dollars to get custom silicon to do anything at a working scale. And then kind of SVMs came and killed neural networks, because for the reason you mentioned, all the people with bigger brains than me, folks like you that understood all the math, went, wow, these are mathematically very attractive, so I'm going to focus on this. Whereas to a kind of boring software engineer guy like me, I was kind of like, yeah, they don't work very well. They don't predict my marketing outcomes very well, or they don't predict the financials very well. So I put everything aside for a while. Then in the kind of early 2000s, random forests came along, and that was like, okay, this is back in my territory. A simple thing, I can code it up into hours. It works great. And so I was the president and chief scientist of a company called Kaggle, which is the world's largest data science community and a competition platform. And I kind of had this unique position there where I saw all the competitions coming in, I saw all the winning solutions, and I saw deep learning suddenly started taking over. And I was like, oh, hooray, neural nets are back and they're working. So I quit Kaggle and decided to really focus on what I've been waiting decades for, which is to bring neural networks back.
Now, the interesting thing about neural networks is whenever we talk about deep learning, there is this baggage of, and I know in America we say math, but everywhere else they say maths, because it feels like deep learning has a lot of extra maths. Yeah. Is that a warranted thing to assume that there's a lot of math baggage in there?
Yeah, so it turns out there's not. So I don't have a PhD myself, and this has been a real boon for me in teaching because I have to make things understandable for me, and that's a really hard task. And so it turns out that the actual math we need for deep learning, so basically you need to be able to add, you need to be able to replace negative numbers with zeros, you need to be able to multiply, and then in theory, you need to be able to take the derivatives of those things. So like, really simple derivatives, although in practice, actually the libraries all do it for us now. So if you can add, replace negatives with zeros and multiply, then you basically have the math you need to do deep learning.
So you've spent a lot of time, it feels like, trying to get people to understand these primitives, but in a unique way. Tell us about the goal of fast.ai and what are some things available to people right now that they can go look at?
Yeah, so let me explain how we think about this. And the way we think about this is heavily influenced by expert educators like Paul Lockhart. The kind of real top educators say that the way you need to teach somebody something is to give them context and get them in the game. So in other words, you need to say, this is why you're learning this, and let's go ahead and use this thing you're learning right away to do something you care about. So the vast majority of deep learning and technical subjects in kind of more numeric subjects are not taught like this. It's kind of like, okay, let's do a year of linear algebra. Now we'll do a year of calculus. And then, we might finally then start to learn about the theory of neural networks. And then in your graduate degree, we might let you write some code. So our approach is the opposite. And it's much more like the way, Microsoft would teach, like, here's how to get going with Visual Studio. It's like, okay, start Visual Studio, type this, press run, and look, the thing pops up and you've created an application. Now to deploy it, click over here and press publish. Now people can use your application. So with our approach, with our book and with our course, within the first half hour, you have created a pretty close to state-of-the-art vision classifier yourself. And by lesson 2, you've written a new vision classifier that no one's ever created before, especially using your own data set that you actually get with the Bing API, and you deploy it for anybody to use as a web application. And so then we have the context, we have the motivation, you're building stuff that matters, and then we say, like, okay, here's a problem. It doesn't understand this category very well, or it doesn't handle false negatives very well. How do we solve that? And then we'll say, right, well, to understand why there's that problem, we need to understand this little bit of math. And we'll say, like, okay, here's this little bit of math to explain everything you need to know. And so here's how we convert that to code. And then here's how you can see that code lives in the library. And then here's how we can use that to solve the problem. So every time we learn a piece of math or a new piece of code, it's within the context of solving a problem. So by the end of the book and by the end of the course, you know a very wide spectrum of kind of deep research topics in deep learning. And a lot of FastAI alumni have ended up presenting papers at the world's top deep learning conferences like NeurIPS and so forth. So it really goes deep, but the whole time it's motivated by practice.
And I want to like, look, I have the book right here. I went through it just a couple of days ago. And the reality of the matter is, literally in chapter 1, you are building, and I'm going to try to open the page. It literally says, your deep learning journey. There's my camera. And you can see, like, literally, it says your first model, and you're starting to classify pictures that look like this.
Right.
And so, and this is not how I was taught.
Right.
But it feels like providing context up front is super helpful. Are you finding success with the people that are taking your course on fast.ai with that?
Very much so. I mean, it's a real problem that the people that teach technical topics like deep learning are the people who have had successful academic careers. And so these are the people who found the traditional approach to teaching technical subjects quite adequate. The kind of bottom up, start with the math, and then spend years and years before you start actually using it in practice. And that means that teachers are different to the rest of us. So we tried to build something for the rest of us, to people like me. I didn't have that technical background. I was straight into business when I was 18. And so it's been amazing to see how well it's worked. So for example, in a lot of business and scientific domains, it's kind of taking over. So for example, in protein analysis, so many scientific papers are now being written by FastAI alumni using the FastAI library. We see in business so many CTOs and so forth from insurance companies, from banks, from telecommunication companies are contacting me and saying, "Thank God for your course and for your library. Everybody who joins our organization, has to do the course before they start, and we find that everybody hits the ground running." Even places that you might think are pretty full of PhDs anyway, like Tesla. Andre Karpathy, who runs the AI group at Tesla, told me last time I saw him, "Hey, everybody who joins this company in my team, I tell them, make sure you've done the FastAI course." I know at OpenAI, which is a very popular research lab, a lot of the residents in particular, are told to do the FastAI course first. So it really is, it's really working great. I couldn't be happier.
And this is cool because it's an interesting distinction between what a scientist might do to push the envelope forward, and what an engineer might do to actually make something work. And you're seeing that success. So we talked about Fast AI. We talked about the course for where can people find the course?
So they can go to course.fast.ai. The whole thing's free. There's no ads. In fact, everything Fast AI does is free. Because it is a self-funded lab, we have no business model. It's just entirely an altruistic exercise. So it's all out there for you to take and enjoy. And all we ask is that you give back by telling others about it and helping out, answer questions in the community and so forth.
So I want to make a distinction with fast.ai as an organization that puts these things together, the course where people can go and take, but then you mentioned something about a library. Tell us a little bit about the library for fast.ai.
So our goal is to not need any code. So that's the ultimate in accessibility, right? So our kind of first step was to say, very, very, very few people in the world are expert mathematicians. Relatively speaking, far more people are expert coders. So let's first of all build something that expert coders can do. So the current FastAI offerings are designed for people who are very comfortable coding. And then our next step is to kind of say, okay, now there are far more people that don't know how to code and aren't expert mathematicians. How do we get to them? And the eventual goal, therefore, is to get rid of code entirely. So our kind of intermediate step there is to make the code like easier and easier and easier to use. Now, we build on top of a library called PyTorch, which is by far the world's most popular library amongst researchers, and it's by far the world's fastest growing library for deep learning. I think for that reason, because whatever the researchers are using is what everybody else eventually ends up using, because the researchers build the stuff the rest of us use. Now, PyTorch, as you know, Seth, is it's brilliant and flexible, but it requires a whole lot of boilerplate. And coders like me hate boilerplate. Boilerplate is particularly problematic for stuff like deep learning, because every line of code that you don't really have to write is a line of code you can get subtly wrong. And unfortunately, in deep learning, you don't get an error message. You just get an accuracy that's like 2.3% worse, and you don't even know that it happened. So we got to get rid of all the boilerplate. So FastAI is a library that sits on top of sits on top of PyTorch, and you write only the code that the computer can't figure out for itself. So you just tell it what you want, and so it's literally 4 lines of code to create a state-of-the-art vision classifier, a state-of-the-art neural network for text analysis, a state-of-the-art collaborative filtering system, the state-of-the-art tabular analysis system. And in each case, the 4 lines of code are nearly the same, because the whole thing is built on kind of time-tested software engineering principles of consistent APIs and a decoupled design and a, kind of very clear API boundaries. So for a coder, it's something you can kind of dive into pretty quickly, and then you can start to kind of peel under the layers and customize things at deeper and deeper levels as you're ready to do so.
And that's the thing I like most about it, because in my brain, because most people don't know this, but I was a dev for 10 years, and then I went to grad school to do this stuff. And so I started making these analogies in my head that a model is just a lazily written function with data. And so you should see similar steps when you're building any model. And I felt like I was writing too many for loops. By the way, PyTorch is an excellent library written by really good programmers, I was writing a lot of for loops. I was doing a lot of data stuff that felt like it was the same. And you abstract those concepts into things like data blocks, optimization, etc.
And this is also great for researchers. So these, it turns out that a lot of what ends up in research papers is basically refactoring. And so we actually ended up writing a peer-reviewed paper about the FastAI library that really is just describing the refactorings that we did. So you mentioned, for example, the optimizer. We've built this, what is, I believe, the first, and it was peer-reviewed, so I think it's fair to say this, the first generic optimizer. So the optimizer is the thing that sits underneath the neural network training and actually makes the weights get better and better at doing whatever you want it to do. And we realized that if we looked across dozens of state-of-the-art research optimizers, and we found there was basically 2 building blocks that they all sat on top of, and we could kind of rewrite the equations in their papers using these 2 building blocks. So then we rewrote the whole lot. in code. So we've created those two building blocks in a generic optimizer base class, and then we subclass that. We'll sometimes use composition, sometimes subclassing, to create all these state-of-the-art optimizers, often with one line of code or sometimes with 2 lines of code. And so it's great for researchers, because then they can say, like, okay, I wonder what would happen if we took the Atom optimizer and replaced the debiasing approach with this different debiasing approach. And you can literally just plug in the different debiasing approach. Whereas if you look at how research code was written before FastAI, people would write their own 200-line optimizer from scratch. Often they would have mistakes, or it wasn't state-of-the-art because they'd missed some important thing like weight decay decoupling or whatever. So they'd spend months as researchers writing code rather than implementing their research.
Even in my fast skim of the book and looking over the library, I was super impressed because, look, I've gotten research code that's been thrown at me from like MSR, for example, and they said, hey, implement this so the customer can see how cool this model is. And it was actually really hard to see, because in research code, maybe you have seen this as well, you can see where the data scientists even changed their mind when they were writing code, and you're like, oh, this should get taken out. And when you abstract certain concepts away, it just makes everything more powerful, I think.
Yeah, exactly. Abstractions are so important. So the FastAI library has 4 API layers, and they're just different levels of abstraction. So at the top layer, we have these higher level API concepts like the data blocks API you mentioned. So the data blocks API came from me after working for more than 25 years with data and machine learning, and realizing there's this handful of things that covers the entire spectrum of everything I've ever done with data processing. So, for example, you have to separate out your data set into a validation set and a training set. You have to label it. Sometimes you have to filter it. Sometimes you have to pre-process it. Sometimes you have to do an on-the-fly transform of an individual item. Sometimes you have to do an on-the-fly transform of a batch on the GPU, so forth. So I just listed down what these things were, and we kind of saw how we can create this really simple little class called data block, where you as a user can say how to do each of those things. And we've actually been really lucky to benefit from brilliant help with that. So when I first wrote it, I used a Fluent API. So for those people that don't know, a Fluent API is that kind of where you say, like, do this, dot, do that, dot, do that. Pretty popular in the JavaScript world. Very popular in the kind of the VBA world with the Office applications. And the problem with the Fluent approach, which was the kind of version 1 data blocks, is, first of all, you don't get great IntelliSense with Fluent approaches, because generally speaking, it's going to be very hard for the language server to know, after all these dots, what kind of object is this thing, especially in Python. Because in Python, we don't really have all that static analysis. And the second is, like, well, it has to be in a particular order anyway. So, why kind of enforce that? So in a recent course, I was lucky enough to be joined by Chris Latner, who developed LLVM and developed Swift and developed Xcode Playgrounds, one of the best programmers I've ever come across. And him and I co-taught a couple of lessons. And he brought along with him lots of other genius Swift programmers, because we did the whole thing in Swift, and we kind of replaced the whole data blocks API with a functional version, and also got some help from a guy called Alexis Gallagher, who's a terrific Swift programmer and author, amongst other things. And between us, we kind of built this new functional data blocks API. And I'm not a functional weenie by any sense, but I certainly really enjoy a lot of the benefits that it can bring. And suddenly it turns out, oh, we can bring that back to the Python world. And so FastAI 2 now has this functional data blocks API where you don't have to worry about what order it goes in. You get IntelliSense all the time, and it actually ends up kind of more concise and more clear. So these higher level APIs, like data blocks, for the user, it ends up being this nice abstraction where they just have to learn one concept, which is data blocks. And then they can do vision, text, medical imaging, tabular, whatever. And then that is built on top of another level of abstractions, which is the mid-tier API. So the mid-tier API is the API that we build the higher level abstractions on. And when you want to change the higher level abstractions, you can use the mid-tier API. And that includes things like transforms and pipelines, kind of lower level stuff. And eventually you get all the way to the bottom and you'll find our optimized GPU primitives. So for example, we wrote our own computer vision library from scratch so that all the transforms actually run on the GPU, which turns out to be really important because nowadays a lot of people find their training code is actually the bottleneck is not the GPU, but the CPU, trying to get the CPU just to deliver the JPEG decoding fast enough or deliver the rotations fast enough or whatever.
And that's quite interesting because, I mean, when you're, for example, to augment your training data, you're going to be doing some transformations on the images anyways. You might as well do those on the GPU. Well, this is very impressive. Like I said, I briefly looked at everything and I was really excited about some of this stuff. I love the expressiveness of the API. We're sticking with programmer type concepts of convention over configuration. And if you want to dive in, you certainly can. Where can people go to find out more? Let's just give them those 3 links and put them up again.
Yeah, so for learning more about the library, go to docs.fast.ai. So docs.fast.ai is where you can learn about the library. You can get started. And one of the really cool things is the entire library is actually built with notebooks, with Jupyter notebooks. And so every documentation page actually is the tests and is the documentation and is the implementation. So you can click on any page. At the top, there'll be an Open in Colab link. And it'll pop open that documentation page with actual working code examples that you can play with. So it's a really nice way to see exactly how things work.
Well, this is really cool. Again, for those that don't know, there's a book also. It's pretty good. I leafed through it and I was very excited about learning more. Now to finish up, I want people to get a sense for your thoughts on the future of deep learning and AI in general, and then we'll close up.
Sure. So I really feel like deep learning, it's another way of building programs. And if we go back to machine learning was developed in the late 50s by a guy called Arthur Samuels. And Arthur Samuels actually made a prediction that one day there would be very few people writing step-by-step code with loops and variables and conditionals, but instead most code will be kind of learnt code. It'll be machine learned code. My guess is that's where we're heading. I think when I look at a lot of the code that I write, I realize a lot of it could actually be automated. A lot of the outputs could actually be automated. Now, one of the concerns is that people think to use deep learning, I need lots of compute and lots of data and a PhD and all these, abstractions. And our focus has been to make sure that's not the case. So we've actually built state-of-the-art competition-winning algorithms that have beaten the world's biggest companies at performance in machine learning using a single GPU with folks that are students with like 3 months of expertise. We've got students that have built really practically useful models with less than 100 images. So, really what I'm saying is deep learning is here to stay. It's going to get bigger and bigger and more important, but you can absolutely get started with it now without huge data sets, without huge computers, and without years and years of linear algebra study.
Well, Jeremy, this has been amazing. Thank you so much for spending some time with us. Again, the book, Deep Learning for Coders with Fastai and PyTorch. If you have the time, make sure to go get it. And if not, go to
Seth, can I mention,
yeah.
That book is also available for free as Jupyter Notebooks. We wrote the whole thing in Jupyter Notebooks. So if you go to our GitHub repo, there's a repo called Fastbook where you can read the whole thing for free. But, buy yourself a copy as well.
Fantastic. Well, Jeremy, thank you so much. I really, really, really love how we're trying to get everyone to do deep learning. I am also like you. I think anyone can learn it. The hardest thing in all of this stuff is basically multiplication and maybe some flattening to zeros. And that's all it is. I'm really excited to have a kindred spirit in this. Thank you so much for being with us, Jeremy.
Thank you.
And again, thank you so much for watching. This has been another episode of the AI Show where hopefully you've been inspired that you don't need a PhD to do deep learning. Just go to fast.ai to learn more, course.fast.ai to actually take the course, or if you want to look at the API, docs www.fast.ai. Thank you so much for watching, and hopefully we'll see you next time. Take care.